Good morning, everybody. I want to welcome you to this webinar about how to improve your weighing accuracy and data integrity. My name is Janterium and I am your host today. In today's lecture, you will learn about the best weighing practices, tips, and connectivity options. We welcome for this presentation a team of people having all a specific relation to this topic. Martin Ross has been in the lab supply industry for over 40 years. Since starting his career in 1983, he has held roles as service manager, sales manager, managing director, lab weighing specialist, and global product manager. Martin joined Sartorius in 2022 as a field application specialist for our lab weighing business area. Martin will be assisted by Viktor Kravchuk, who has been with Sartorius since 2021, joining us with extensive experience in the integration of software solutions in the field of laboratory diagnosis, LIMS and laboratory automation. One of Victor's main responsibilities in his role as a field application specialist is to help our current and future customers with the integration between their Sartorius balances and a LIMS or similar software system for digital data transfer. But before we begin the session, I would like to inform you that we will be recording this meeting. The recording will be sent to you after the session, and you can also access all the recordings of past and future webinars on our Avantor website under the Events section. Additionally, we will be providing a certificate of attendance to all participants after the session. Since we have many attendees today, we kindly request that you submit your questions at any time using the question function, but we will answer them at the end of the session. Finally, we really would like to have your feedback after the webinar. So if you could take a moment to fill out the survey at the conclusion of the session, that would be great, as we always want to improve for the future. So with this all being said, I would now like to introduce our first speaker, Martin. Thank you.
Thank you, and good morning, everybody. Hope you're all well, and thank you for joining us this morning. The first part of this presentation, this webinar, we're going to look at weighing fundamentals. So looking at influences on the balance, how we can improve our results, how we can mitigate influences on our weighing process. We split this into three sections. So we're looking at balance specifications, environmental influences, and then lastly, influences from samples and the operator. Our first specification here is repeatability of the balance. Now, repeatability is the most important specification on the balance. It's in effect, it actually tells us how good the balance is at giving the correct data time after time. So we actually do a repeatability test on the balance by placing a weight, usually around 5% of the load, the maximum capacity of the balance, 10 times, and calculating the standard deviation of those 10 weighing replications. From this standard deviation, we can tell how good the balance is. So if you can see here on this graphic, usually we're using a confidence of 2, which represents 95.4% of all measured weights, which should lie within that band you can see on that graphic. So repeatability of the balance is one of the most important specifications that we should look at to tell you the quality of the balance and how good it is at giving you correct results. And the next specification we look at is linearity. Now, linearity, as you can see on this graphic here, is the deviation from the line from 0 to maximum. So the straight line between the 0 and the maximum capacity of the balance. And any deviation from that point is what we would call linear error. Obviously, we wish to keep this error to an absolute minimum. And once again, the quality of the balance and when it has been manufactured is determining how large or how small that linear error is. Ideally, we wish to keep that absolutely as small as possible. If you look at a datasheet specification for a balance, you will always find a specification for linear error. And when you do that, please make sure that it's as small as possible. The third specification we're going to look at is corner load error. Corner load is exactly what it says. If you don't place your sample and your tare vessel in the center of the balance, you will be incorporating an error. This error we call eccentricity or corner load error. Now we actually test this error on balances by placing a weight in the center of the pan, zeroing the balance, and then placing systematically at the 4 different corners of the pan to actually find out how much linear error is on that particular balance. So for example, on a 5 decimal place Cubis 2 balance with a 220 gram capacity, a typical maximum eccentricity deviation should be 0.1 milligram. So we want this to be absolutely as small as possible. Linear error can be adjusted at the factory by the manufacturer to be as small as we can make it. Now, the fourth parameter that we're going to look at is the sensitivity of the balance, or what we would call calibration and adjustment. In other words, the slope of the balance between 0 and capacity of that balance. A small misconception about calibration and adjustment: people talk about calibrating their balances. Well, yes, calibration of the balance is to determine the difference between the slope where it should be and the slope where it is. In other words, that sensitivity error or slope error. Is the slope too steep or is it too low? We want that slope to be from 0 to maximum. And then once we determine that, that calibration error, we then adjust the balance. So that's the difference between calibration and adjustment. Adjustment we can do using external weights, which are traceable. We can also do it using the internal weights on the balance. Many balances nowadays have internal calibration facilities, which are triggered either by temperature or time. On Sartorius Cubis 2 and other balances within the Sartorius range, we have ISOCAL, which is our automatic calibration and adjustment, triggered by temperature and time. So now, having looked at the balance specifications, one thing just to say, those 4 balance specifications which we've looked at will combine to produce a measurement uncertainty. So we take into consideration all of those 4 errors, and then we can actually quantify any measurement uncertainty by combining them together in the root mean squared effect. So moving on to environmental influences, these are very things which we can and cannot control, and we can, if we work hard to mitigate these, reduce the overall error on the balance. We all know that a balance should be level before you use it to weigh, but what sort of an error does this introduce if the balance isn't level? This is a small example of how much error can be generated by a balance which is not leveled. So in this example, by placing a small business card under the feet of one of the balances to develop an out of level scenario, we're looking at a 400 micron lift on one side of the balance, and that generates a 0.37 milligram error, so 370 micrograms of error into your weighing process. You can see there in the calculation. I'm not going to go into details, but the error is the cosine of the angle which is developed from the vertical to the new line through the balance on its inclination. So we want to level the balance before we use it. How do we do that? Well, in its simplest form, most balances will have a level bubble. Nowadays, we have electronic assisted leveling on the Cubis 2 balance, the balance detects when the balance is out of level. It informs you on the display, and then at the touch of a button, we have automatic motorized leveling, which will bring your balance back into level. Once you've leveled your balance, you should, of course, perform a calibration as well to make sure that the slope of the balance is correct. We can also use the balance in safety cabinets, and automatic leveling in safety cabinet is particularly useful rather than having to stretch into the cabinet to level your balance. So what about our environment? If we think about our laboratory where we're placing the balance, is there sunlight, direct sunlight coming through the window towards the balance? We all know that balances are made up, particularly the weighing cell is made mainly of metal. So that weighing cell is going to expand and contract according to the ambient temperature. So if we have direct sunlight on the balance, heating the balance up, that will expand the weighing cell and create an error. The balance will then need recalibrating. Do we have open windows? Open windows will create a draft, an airflow. Do we have a good table, or do we have a good bench or a weighing stone? Or do we have an unstable table? Is that table located in the center of the laboratory? It's better to be located at the side of the laboratory or against a wall for more support. Do we have any vibrations near the balance, or a piece of equipment on the same table as the balance generating vibrations? Do we have air conditioning in the laboratory? Is it over the top of the balance? Every time we open a door into the laboratory, this creates an air current. So in high-class laboratories, it's better to have sliding doors which just cut through the air. What about humidity in the balance and the temperature? And also the general hustle and bustle. All of these things, think about these and try and mitigate them if you can to give yourself the best conditions to weigh in your laboratory. So each balance, once again, will have a classification or a specification for temperature sensitivity. So in other words, how much will the slope of the balance change with changes in the temperature, the ambient temperature in the laboratory? This is normally given as a number of parts per million per degree Celsius or degree centigrade or Kelvin. For example, on a 5 decimal place cubist balance, the specification is 1 part per million per degree. So if we calculate this out on a 100-gram weight, we would have an error of 100.0005. Once again, we have to adjust the balance if the temperature has changed in the laboratory. So our solution on this would be the internal calibration, in our case, ISOCAL. Let's think of the location of the laboratory and the gravitational acceleration, which is a significant influencing variable. If you think about it, the higher up you are in a, let's say, a 10-story or 20-story block of flats, the less is going to be the gravitational effect. So what we're saying here is wherever your balance is located, that's where it must be calibrated. If you use traceable masses, then you will be able to be confident that wherever your balance is on the ground floor or on a higher floor, that your balance will have the correct slope on it to be able to give you confidence in your results. In addition to this, we also have to consider the latitude of the laboratory on a global scale, because the G-force is different on different degrees of latitude. This can be adjusted at the factory, but by far the best option is to get an external trained calibration technician to adjust your balance exactly where you're going to be using it and issue a calibration certificate. Let's talk a little bit more about the ISOCAL function in Sartorius balances. ISOCAL compensates for changes in temperature, in barometric pressure or humidity, and also changes in the location of the balance, as we've just talked about. On high resolution balances, the activation criteria for adjustment, for automatic adjustment, is 1.5 degrees Celsius or Kelvin. or at 4-hour intervals, the balance should automatically recalibrate itself and adjust the slope. Let's move on now to the third and final section of the first part of our presentation. Influences from samples and the operator. So again, hopefully things that we can change to ensure that the error that we're introducing into our balances is at its absolute minimum. Electrostatic charges are particularly difficult to deal with and can create immense problems in trying to dose our sample into a tear vessel. If you think about small powders, they will rub against each other in transit, and this creates a static charge on the surface of these plastic granules, or whatever our sample might be. If we therefore have a charge on our tear vessel, if it's positive or negative, this will have an effect on our weighing result. In the first graphic there, you can see that our particles are negatively charged and negatively charged tear vessel. This is creating a downward force, so our error will be positive. In the second graphic, you can see that the charges are negative. This will create a repelling behavior, which will lift, an attraction behavior. This will therefore lift our tear vessel and make our sample appear to be lighter than it actually is. How do we deal with this error? Well, we can have anti-static corona introduced into the draft shield to discharge any charge on our tear vessel, and then also on our sample. You can see on this Cubis 2 on this picture on the left-hand side, you can see the 4 points of the ionizer within the draft shield. Now, on opening the draft shield, the ionizer can be set to automatically activate for a length of time, and this will discharge any charges on our sample or tear vessel. And then when we close the draft shield, we should have no influence and no effect on our weighing process. Static appears typically at a very low humidity. So if you can keep your humidity above 35 to 40% in the laboratory, you will have less effect of static influence. Magnetic samples can also have an influence on our weighing process. If you think about the weighing cell in a balance, this is built by using a magnet. The whole process is electromagnetic force compensation. That's how our weighing cell works. So anything which is magnetically charged will be influencing the magnet in our weighing cell and creating an error in the weighing process. So the behavior of the balance is that the weight values will be stable, but they will be incorrect and they will not be repeatable. So some tips here is do not weigh with a magnetic stirrer in the vessel. If you can, demagnetize your sample, or you could use mu metal, which is a foil, a shielding foil on your balance pan to prevent any magnetic charge from getting through to the weighing cell. Or on many balances nowadays, there's the ability to weigh below the balance. So there's a small aperture underneath the balance where you can connect a hook directly to the weighing cell and you can weigh below the balance without any magnetic influence. In addition to this, we have nowadays many sample holders to hold different tear vessels. So we're talking about stents for stent weighing, weighing papers for weighing and weighing boats, weighing filters, so 37mm filters, 90mm, 110mm, round bottom flasks, safe lock tubes, syringes, reaction vessels and reaction tubes. This gives us more stability, better handling process, faster response time, better repeatability, and therefore a smaller minimum sample weight. It also reduces magnetic influences and reduces spilling in the weighing pan. Let's now talk about air buoyancy. If we think about it, air has a mass and therefore we have to think about how this mass interacts with our weighing process. If your balance is drifting, it could possibly be an air buoyancy effect. Let's say, for example, your sample is too hot and hasn't stabilized. As it cools down, your weight will decrease. Opposite to this, if your sample is too cold and the weight warms up, your weight will appear to increase and not be stable. So what we should do here really is acclimatize our sample in the laboratory next to the balance, or even inside the weighing chamber, excuse me, before we start the weighing process. Hygroscopic samples, or samples which absorb moisture. If you think about your salt pot in your cupboard, sometimes if it's very humid, you can go to your salt pot and all the salt is stuck together. That's because sodium chloride is hygroscopic. So our sample, if it's hygroscopic, will absorb moisture from the atmosphere. That will make it appear to be heavier than it actually is. So it does depend on the substance itself and the humidity in the laboratory. So efflorescent substances themselves cause a weight change, and you can have different results excuse me, when weighing samples at different times according to the humidity in the laboratory on those separate occasions. Opposite to this, of course, if we're weighing a solvent or something which evaporates, then evaporation of that liquid will cause a decrease in the weight depending on how long it takes to complete the weighing process and how volatile your sample is. Some tips we can offer here are to use a narrow necked vessel, or one covered with foil or a laboratory seal. Stabilize your sample once again in a desiccator before weighing, and also work swiftly or quickly to ensure that the absorption of moisture or the evaporation of moisture doesn't have as much of an effect on your weighing process. Let's once again think of your workspace. So the table itself should be solid built, made of stone or synthetic stone if you can. Always place your balance over a leg or a corner if you can do, not in the middle of the table where there is no particular leg support. Avoid bending the tabletop or lean on the table while you're doing your weighing. Set up your balance in a vibration-free location. No machines or other equipment which will generate vibrations or electromagnetic fields near to the balance. Always position your balance table, if you can, in the corner of a room or at the edge of a room near a wall where you will have more support and less vibrations. Avoid exposing it, as we talked previously, to sunlight, direct sunlight, and any infrared radiation emitted by lamps or heaters. Avoid airflow, so the airflow rate should really be less than 0.2 meters per second if possible. If there's an air conditioner in the laboratory, position the balance in the opposite section of the laboratory to the air conditioning, so that it doesn't have any effect or has minimal effect on your balance and your weighing process. If you can, control the laboratory environment and create a constant environmental and ambient conditions within your laboratory. So if we can, we should have control the temperature within the laboratory and the relative humidity, if we can keep it constant and preferably not dropping below 40%, as we talked about before, because that increases the effect of any static electrical charge. We do have on Cubis 2 a climate sensor option, which clicks into the back of the draft shield, which measures temperature, barometric pressure, and relative humidity to monitor the climate conditions. We also have the option of the inbuilt Cubis 2 ionizer, the 4-point ionizer, to completely eliminate any static charges on your sample or your tare vessel. And we talked about thereby increasing the humidity within the laboratory, if you can, to 50 or 60% to reduce the effects of static charge. That brings my section of the presentation to an end. Thank you for your attention. I'm now going to pass over to my colleague, Viktor Kravchuk, who is our specialist on data integrity and connectivity options for balances within the Sartorius range. Thank you, Viktor.
Thank you very much, Martin, for your contribution. Hello and welcome. Today I'd like to talk about connectivity requirements for modern lab instruments and how data integrity issues can be avoided in the lab. Next slide, please. The presentation today is interesting for a variety of stakeholders because there are many factors to consider when buying a new laboratory instrument. I believe that the most crucial is the ability to deliver reliable results. The laboratory staff, however, also needs a tool that is simple to use, helps them with their everyday tasks, and boosts the lab's productivity. On the other hand, the QA is responsible for making sure that all compliance criteria are met. And in this case, it is crucial that a device supports compliance without impeding the user's ability to perform their daily tasks. Finally, the IT department is a significant participant in the modern world. For them, the major concerns are to make sure that the solution is simple to incorporate into current and future IT infrastructures, complies with all security requirements, and doesn't need a lot of support or maintenance. As you can see, there are strict criteria for modern laboratory equipment, particularly when it comes to an essential device like a balance, which is used in many different areas like production or QA. Next slide. I'd like to begin by giving a brief overview of data integrity. After that, I'll present examples of various data integrity violations from FDI warning letters and discuss how these can be avoided by using modern laboratory equipment. Next slide, please. So, why is data integrity so important then? All our decisions, for instance, a batch release, are based on data from our daily laboratory work. If we have inaccurate data or incomplete information, this causes us to make wrong decisions. And wrong decisions increase the risk of compromising the safety and quality of our products. We are aware that if a product is not safe and of the highest quality, it may increase its cost, and more importantly, it can endanger the health and safety of our patients, and this will ultimately degrade confidence of our patients, clients, and other stakeholders. And additionally, we damage the reputation of our company, so it's really crucial to make the right decision based on the right data. Next slide. So, what is data integrity? With data integrity, we want to cover a few major goals. For example, we need to ensure that the data isn't inaccurate or incomplete. On the other hand, we want to ensure that besides being recorded exactly as intended, it remains the same, and this over the entire data lifecycle. And we know that depending on the various restrictions, the data lifecycle in a GXP environment can range something from 20 to 30 years. But as we'll see in the following slide, using electronic and computerized systems allows us to work more effectively and reliably with our data. Next slide. The mentioned violations in FDI warning letters that I mentioned before, where data integrity issues were present in more than 50% of all letters in the previous 10 years, further demonstrate the importance of the topic. This demonstrates both how diverse the infractions are and how strongly the problem of data integrity is in the audit focus of several authorities. This could, for instance, mean that an SOP was not followed, or that there was simply no SOP. Remember that the incomplete or incorrect transmission of data can apply to both digital records and manual data transfer, such as from a lab notebook to a simple computer. Another frequently discussed subject is anything related to the audit trail, such as whether a device had one whether it had been disabled, or whether the auditory records had simply not been inspected. Later, I'll provide some illustrations of this and demonstrate how digitalization and modern laboratory equipment successfully mitigate these problems. Additionally, you should never forget that data integrity applies to all types of data, not only electronic ones. The same regulations apply to paper-based records as well, but in daily laboratory life, a solid and well-planned digital method is frequently far safer and more effective. Next slide. How to achieve data integrity? To ensure the accuracy, consistency, and reliability of our records, we must first follow proper documentation and practices and the ALCOA principles. What is ALCOA? In the first place, it means attributable, which denotes that the record includes full metadata. That means username, instrument ID, timestamp, rather than just a vague value without any more information. After that, our data or record must be legible, sometimes referred as to traceable. What it means? It means that anyone who may study the record afterwards will be able to read it, to comprehend, and fully reconstruct the data. We must also record our data as it's being generated or observed. In this particular case, digitalization and connected systems are particularly helpful because in these types of systems, the value is typically immediately stored electronically by the system without requiring a manual data transfer. Additionally, the data must be original. Original data refers to the first instance in which the result or information was recorded. This data must be readable for the duration of the retention period, as mentioned before, which can be 20 to 30 years in GXP environment. Therefore, whenever it is possible, utilize standardized data formats rather than vendor-specific ones, so that the data may still be read in the future. Finally, we need reliable data. This indicates the data is accurate, comprehensive, and trustworthy. This involves, on the one hand, that the system is qualified, much like a laboratory balance, and that the verified state as well as the data itself are periodically examined. On the other hand, if errors are discovered in the record, for instance, these errors and their corrections are clearly documented with the cause, the timestamp of the correction, and the signature of the person who made the corrections. So let's go to the next slide, please. So you should ensure that any new laboratory equipment you purchase has all the necessary technical characteristics to enable you in executing the data integrity requirements. What are these features? The instrument should have a detailed audit trail. You should be able to manage users with customized user accounts and also have an electronic signature. Another helpful and really important feature is time synchronization. You should offer various interfaces and protocols for the secure data transfer of the results into another software system such as LIMS or ELN, and should have a backup option. In the following slides, I'll demonstrate how to avoid data integrity problems using example from our QBIS 2 balance. All these functions are offered by Sartorius QBIS 2 balance without the requirement of any additional PC-based software or middleware. As a result, you may integrate the balance into your LIMS or ELN system easily, and the expenses associated with validation and maintenance are also decreased. Next slide, please. Okay, this is our first illustration from the FDA warning letter. It demonstrates the significance of user management and customized user accounts. In this example, an operator used a shared user account, making it impossible to determine who generates the data or modifies the system settings. Therefore, every user should log in into their own unique user account. It should be a personal account, and the user the system needs to include functionality to stop other operators from using it. Let's say complex passwords, account locking after an excessive number of failed login attempts, or even automated logout after inactivity are example of this. A central administration of the users accounts is highly important, especially with a crucial laboratory tool like a balance. The best option would be to directly integrate the instrument into an Active Directory or a centralized user management server without using any intermediary software. Using these features is possible with the Sartorius QBIS 2 balance, which simplifies handling for user by removing the need for remembering passwords for different laboratory platforms. In this case, the users may sign in using the password for their Windows account, and it also makes administration easier and quicker. Next slide. Well, in this example, the users did not simply use the shared account. This account also had administrative rights, which would have allowed changing other system settings, such as the date and time. A modern laboratory system should incorporate role management in addition to user management, so that users can only access the areas necessary for their regular laboratory work and cannot alter crucial system settings. Role management should also be adaptable so that roles and the associated access rights can be modified to meet the demands of your business and adhere to relevant SOPs. This illustration also highlights the significance of timing properly. Manually changing the system date and time should no longer be a case when working with modern network devices. The instrument's time can always be adjusted with the help of an automatic time synchronization. And this is crucial because all computer systems in some moment, after some time, will show some clock drift. So that means that the system time eventually deviates from accurate or real time. On QBIS 2, it is possible in few steps to synchronize devices date and time with help of an available network time server. Next slide, please. Okay, as you can see in this example, issues with the audit trail are frequently encountered as well. The audit trail in this example was either not activated or it was possibly to be activated, making it impossible to detect system modifications like changing the time or deleting data. Once more, this results in data integrity violations, so you should always purchase a lab instrument with an audit trail. It shouldn't be able to turn it off in the best case scenario. The audit trail must also be simple to read and comprehend because it will be often examined for irregularities. Since it is easier to review it on a PC rather than on the instrument because of the huge amount of data, you should have the option to export the audit trail file for external analysis. Of course, sorting and filtering options may also be quite useful for locating specific audit trail data, and all this is available on QBIS 2 balance. Next slide, please. Okay, the following violation is about the reports that were not signed and therefore are not assignable to an individual. This can be prevented very easily if the system is forcing electronic signatures before a report is created. Along with very strict passwords and personalized user account settings, you have then a proof and clear assignment to each record. This is an example how a digitally signed report looks like on a QBIS 2 balance. Next slide. Okay, in addition to data integrity itself, which also refers to paper-based data, the presentation's second focus is connectivity, which improves the security and effectiveness of processes and data transmission. Next slide. In this slide, I will give you an example of digital and compliant paperless documentation workflow and how this can look like. We will use the Sartorius QBIS 2 balance, where we have implemented this kind of workflow directly on the balance. First, you need a feature to review results before you create a report. This can be done directly on the balance. In case there was an error during the measurement and you need to mark the wrong value, you can do it directly on the balance by flagging such result as invalid and write your comment or course on the balance touchscreen. Thus, when you have reviewed your results and made the corrections, then you can directly sign it on the balance with your electronic signature. And this is a very useful feature because you don't have to switch between the PC and the balance and can continue your work on the device. After you have signed it with the electronic signature, you will create a full compliant record with all the required metadata. And in the last step on QBIS 2, now you will have several possibilities to generate and transfer a report to different systems. We will see now what options are available. Next slide, please. Okay, QBIS 2 offers future-proof options for integrating the balance into different systems. We know that not every company has, or not every lab has the possibility to integrate equipment directly into a laboratory software such as LIMS or ELN. On the other hand, many labs are planning to do so, to do such integration soon, but want to start using a balance now. QBIS 2 actually grows with your digitalization requirements, so it is possible to use digital documentation workflow as shown in the previous slide, but still work with a normal lab printer. In this scenario, you have a paper-based solution, but instead of handwritten signatures or crossing out invalid entries, it is possible to do this electronically, directly on the balance. And when the moment comes and the balance is on the network, the paper-based reports can be turned into PDF files that are sent to a network shared location or a document management system. This is a very step in going completely paperless, but still compliant. If later you want to integrate QBIS 2 balance directly into a LIMS or ELN, also here our balance offers different possibilities for a full compliant integration or network without the need for any additional hardware, converter, middleware, software. Probably the simplest way of integration, what is also directly supported by most of the LIMS and ENL systems, is when you create a report as a text file, for example, ASCII format as CSV file format, and transfer it to a network share, where this file is parsed by the mentioned software systems. The other scenario that is possible on the balance is to create a direct connection to a LIMS by using one of the communication protocols that are available on QBIS 2, such as the SBI protocol or the SIX protocol. Another standard solution that we employ in QBIS 2 are the REST web services. This API is used by many software systems to communicate in a bidirectional way with many laboratory devices. Thus, it is offering a seamless integration between the balance and the external IT systems over the network. I will now show you some slides with less text and more graphics for you to better understand most data communication capabilities of the QBIS 2 balance. Please, next slide. Okay, so in this slide, you see the communication of between the QBIS 2 balance and Active Directory server, where the user accounts are stored. And for that, you basically need the Ethernet wireless connection. Next slide. This is a time synchronization protocol. So the only thing you need is the connection. The balance has to be in the network or on the wireless network or with the Ethernet cable, and you then configure the NTP server, and your date and time are synchronized automatically. Next slide. Connecting the printer is very easy. You can do that. You can connect the office the big office network printers over the Ethernet or wireless connection, or you can use the thermal printer using the USB or serial connection. Next slide. This is the option I mentioned in the previous slides, that the balance can generate reports in PDF and CSV formats and store them, for example, on the FTP server or on a network shared location using the SNB protocol. And for that, you need the balance to be on the network. Next slide. We also have on Cubis 2 a so-called PC direct mode. That means that you can transfer, in this scenario, you can transfer your results directly into Excel, which is installed on a computer, which is connected with an USB cable to the balance. No middleware is required in this case. Next slide, please. The following slides will be a little bit about this the direct integration with LIMS or other software systems using the built-in protocols that we have on the balance. We have a couple of them. So this is the Sartorius balance interface, and it is supported. So it can you can connect using the Ethernet cable, wireless, USB, or serial connection, and you can use this protocol. So it's a bidirectional protocol, and the external system, for example, a LIMS, can control the balance. I can send a command such as return the value, return the weight value, execute zero TF function, restart the balance, etc. Next slide, please. We also have the 6 protocol built in on the balance. So it works in the same way as the one shown before. Only the syntax is different. You can also query for different parameters on the balance, and the balance will return then, for example, the balance model name, the serial number. We can write a text on the display, etc., etc. Next slide, please. And this is the modern approach. So we have the built-in REST API on Cubis 2 balance. It's also a bidirectional protocol and also supports a number of different commands to get different metadata out of the balance. It works over Ethernet and wireless. Just to mention that all the 3 examples that I have shown, they don't require a specific license. So the integration is made not only easy, but also cost effective. Next slide, please. The protocol description. So if a customer wants to integrate with a LIMS or another software or hardware system, but they don't have the communication driver on their side, we can deliver this the description documents that will help the other side to develop the corresponding communication driver. Next slide, please. We also support, not natively, but we have an OPC server as middleware, just to connect in some scenarios with the systems that require the support for the OPC format. So that means that the software that we offer converts the standard SDI protocol into the OPC DA format. Next slide, please. And some customers, they also still use the wedge product. It allows to connect multiple balance to one single computer, and then it allows to insert the values, that the results from the balances into almost any Windows-based program such as Excel, Notepad, Word, etc. Next slide, please. And the last, what I wanted to mention in terms of the connectivity, we have our own brand new software, which is called Ingenic Suite. Next slide, please. Here in scenario A, you see a normal scenario where our balance acts as a standalone device and connects directly to an ELN or a LIMS system. But if a customer or a laboratory wants to extend the features and have more value, they can put Ingenic Suite in between or as an end integration solution to do more interesting for more interesting options, and I will show you them in the next slide, please. So we can, with Ingenic Suite solution, we can do the balance fleet management. It means we can connect multiple Cubis2 balances and add them in one database in Ingenic Suite. With that, we can, for example, upgrade the firmware remotely from every balance connected to the software. We can receive the audit trail information from all the connected devices, balances. We can review this audit trail. We can sign them electronically. We also can receive in Ingenic Suite the reports from the applications on the balance, and also can review and sign them electronically. And we have also the possibility to do the external calibration of the balance with external weights. Next slide, please. And it is also possible to use Ingenic Suite for the advanced pipette calibration according to the new ISO 8655 norm. And for that, either a Cubis2 balance or a third-party calibration device can be used. Next slide, please. So just to mention some of the features of applications that are available on the balance. So we have a so-called connectivity pack, which include applications pre-installed on the Cubis2 devices. And some examples are the Omnis connector or the Starlinks connector. Next slide, please. Well, this is actually the end of my presentation, and please feel free to contact us or visit our website for more information about Cubis2 and the integration solution that is possible to have with the balance. Thank you very much for your attention, your time to listen to this presentation, and I really hope that this has given you an insight into the problems of data integrity and connectivity of laboratory instruments. Thank you very much.
Thank you all for your attendance this morning. There's a couple of questions which we have in the chat. If I could just go through those for you. Here's one for you, Victor. Is it a data integrity requirement to give raw material batch number information when weighing the raw material?
Yes, it's possible to enable the batch and sample ID concept on the balance. So it's very flexible and configurable. So when you start to weigh in a sample, the balance prompts you to enter the batch ID of the sample and or the sample ID.
Thank you very much, Victor. We have another question here. I was wondering whether using anti-static weighing cups helps for weighing accuracy, and if yes, in which conditions exactly should we use them? Well, yes, I believe you can purchase anti-static weighing boats. So if you know that you have a problem with static electricity or charge, either on your tare vessel or on your sample or on both, then by using an anti-static tare vessel can help the situation. Or of course, if you have an ionizer, as we talked about earlier, an anti-static ionizer, this will fire a corona into the weighing chamber, which will discharge any charge which is residual on either your tare vessel or on your sample. We have another question here. Good morning. Is the balance capable of doing measurement study analysis into operator variance, for example? Well, yes, we don't provide a template for this, but of course you can connect your balance to, as Victor mentioned, directly connect your balance to Excel. So I would imagine it's quite simple to do an inter-operator study by using the user management facility on a Cubis2, for example, and by sending the data in terms of which operator has been doing the study, and the data from that process into your Excel template to further manipulate the results and obtain the results that you need for your study. Okay, will you have any presentation on the qualification of the balances? We do obviously operate qualification of the balances, and it's a good idea in a highly regulated environment to have your balance qualified on site in the laboratory where they're going to be used. So we offer IQ, OQ validation services as a company on balances. The documentation is already written, so it's a case of the trained technician performing the validation on site on your balance, producing a certificate, and for example a minimum weight certificate as well if you require that for your balance in your own laboratory. I don't think we offer a specific presentation on qualification of balances, but if you need any more information, please don't hesitate to contact us. Can you please share tips for the weighing toxic substances in a flow hood? Well, of course, in a laboratory, it's normal to have an extraction cabinet or a flow hood to take away any toxic vapors for safety, safety reasons, obviously. We mitigate this by, in the balance, we have various filters. For example, we have one which is called weighing in a fume cabinet. So if you enable this setting, the balance will integrate the weighing signal, and it will do its best to actually minimize the effect of any either vibrations or any air current effects within the fume cabinet itself. So there are various settings on the balance which we can use to try and mitigate any of these external influences. Okay, next question. If I have the balance 1 meter away from HPLC and computer, would the vibrations affect? I think this really depends on what vibrations are actually generated by your HPLC. To my mind, they don't generate an awful lot of vibration, but obviously the best scenario is to have the balance on a completely separate bench. You can, of course, use a balance weighing slab, which are relatively inexpensive, with rubber or sorbitol feet. These absorb as much vibration as they can. You can also get air vibration as slabs, which you can actually tune into the particular frequency which is of the vibration which has been generated. These are a little bit more expensive. They're not produced by Sartorius, but you can get them on the market. And those will be able to tune out any particular frequency of vibration which you find on your bench. Please share tips for cleaning of balances. This is an excellent question. We've just introduced on the high capacity microbalances in the Cubis 2 range a cleaning Q app. Now this is a small application which will remind you whether you need to do basic or advanced cleaning on your balance. It's integrated into user management, which is also recorded in the audit trail. So you can check whether somebody has agreed that they've cleaned the balance, either a basic or an advanced clean. What's really nice about this particular Q app as well is it shows you by way of a wizard, and it walks you through the cleaning process. So it shows you which parts of the balance to disassemble in which order and which parts of the balance to clean. It also shows you then, once you've cleaned the balance, how to reassemble the balance. This cleaning Q app will be rolled out into our Cubis 2 range, across the Cubis 2 range, so into analytical precision and semi-micro balances and our micro and ultra micro range in due course. We just have a couple more questions left, so we'll try and get through those if we can. Any tips to weigh charged substances on plastic tubes due to electrostatic effects? Powdered substances tend to fly in the outside part of the tube instead of going down into the inside. Yes, this is exactly what we've talked about before. This is exactly the scenario which you'll find if you've got either a glass or a plastic charged tube, and then you introduce a sample with either the opposite or the same charge, you will have particular problems dispensing that sample into your tare vessel. You can have either the inbuilt ionizer in the Cubis 2 range, or we offer some external solutions as well to be able to put these next to the balance, so you can pass your tare vessel through the field in the external ionizer. Then of course you can pass your sample through the same field to discharge it as well. And the last question we have here: when weighing, must only the net mass of the sample be considered, or can the vessel mass be included? Victor, do you want to answer that one for us?
Excuse me, I don't see the question actually.
Yeah, okay, no problem. I can read that again. Yeah. When you're weighing, must only the net mass of the sample be considered, or can the vessel mass be included? So the tare mass, can that also be included?
Well, if you work with a vessel, you first must to tare it, the vessel, and then you get the net value. But when you send these values to a limb system, for example, you can transfer both the gross and the net value and the tare and the tare value. So it's you get on the connected system, on the limb system, 3 different weights. If you want, this is configurable.
Thank you very much, Victor. And the last question we have today is: we have a lot of students and guests in our labs who move the balances from room to room and just move the balances on the table to make more room. If the balance is calibrated, is that okay, or should it be prevented? Well, I'm guessing that you're not in a highly regulated environment, but as I mentioned before, most balances will have internal calibration on them. So a good tip is also to always do a internal calibration on the balance as soon as you've moved it. Let it acclimatize. Once it's acclimatized, perform an internal calibration on there. Also check the balance with your external traceable weights and make sure that the balance is within tolerances. If you do this, this gives you a certainty that the balance is in calibration, it's been readjusted, and you should be good to carry on. Except when you're in a highly regulated environment, when if you do move the balance from a laboratory to a laboratory or from bench to bench, your official calibration will be invalidated, and you should really get the balance recalibrated. So either get a recalibration done by your service technician, or don't move the balance in the first place. I hope that answers that question. Thank you very much. That concludes all of the questions which you've asked. Thank you for those questions and the interactions which you've given. If you do think of any other questions, please don't hesitate to contact us, and we'll do our best to support you.
Thank you, Martin and Victor, for this valuable presentation. Thank you also for the audience for joining us in this webinar. I trust that you found it valuable and that your time was well spent. So, as said, if you have more questions, don't hesitate to ask them by mail, and we will come back to you. Look forward to meeting you again in one of our upcoming webinars we will organize, and wish you all a very nice day. And thank you for the speakers again. Have a nice afternoon. Bye.